Hey, I'm Miss Johnson. Welcome to Calculus. Today in class, we talked about how to use calculators to find definite integrals. And we also talked about some foundational rules for definite integrals. And we just want to keep working on that kind of stuff. So we're going to uncover more rules during this assignment by exploring one, using definite integrals, kind of the same thing we did in class, just with another function, like another rule. And then the last half of the assignment is I just wrote up a bunch of rules, and some of them are true and some of them are false, right? And we're going to kind of do some research mathematician stuff and uncover whether we think these rules are true or false, right? I'm going to do 3 examples on the video, and then you're going to do, I think it's 5 examples on the assignment. They go by quick. So let's get going. First, I want to put in video format the way to use calculators to find definite integrals, just in case you need to reference this later. We talked about 3 ways to do this, which is using Desmos, using Wolfram Alpha, and using a TI-84 Silver Plus edition, but whatever. Let's go over those now. So for Desmos, we're going to go to desmos.com, boom, /calculator, the graphing calculator for Desmos, right? And as soon as I type in int for integral, right, I'm going to type in an I, I'm going to type in an N, and then watch this. I'm going to type in a T, and it's going to turn into an integral sign. Good. Thanks, Desmos. So if I wanted to come down here and do this blue definite integral, which is the integral of e to the x from -1 to 1, I would type in a 1 on the top, a -1 on the bottom. I would type in e to the power of x. The way I got the power is I did shift 6 with the caret, e to the power of x. Scroll over, write dx, and then in this little corner it tells me that the integral is 2.35 plus some other stuff, but we're feeling fine. If you instead wanted to use, so I know that a lot of people are comfortable with Desmos. I prefer Wolfram Alpha just because I'm old, and that was the computational engine of my day. So if we use Wolfram Alpha instead, we would just type in what we want to do. We'd say integral of e to the power x, and it's just the power again is the shift 6, it's the caret, dx from -1 to 1, I think is what I wanted to say for this next green example. Nope, it's from 1 to 3. Bada bing. And then it just simply tells me what's going on. If you pay for it, you can do step-by-step solutions, but that's money. So again, this one allows you to check, just like Desmos, to make sure you typed it in right. And then we said that it's 17.37, say. Nice. So the first half of the assignment is doing stuff like this, and then making a rule based on your findings from what you find from that. For the TI-84 Silver Plus edition, I'm going to go through the steps, and then I'm going to make my screen huge so you can see my own calculator. You're going to enter the function y equals. Then you're going to make your window reasonable. That's the window button. This tells you when you graph it, which part of the graph you're looking at. The main thing is we want our x minimum to be below our lower bound and our x maximum to be above our upper bound. You're going to select calc, which is the second trace button. Select option 7 just by typing 7. And then you just type in your lower bound, type in your upper bound, and then it'll show a number at the bottom of the screen. I'll tell you what, if you want me to show you that, I will show you during office hours, but it's actually kind of cumbersome to have the calculator up there. But that's the way to do that. And this is the one you'll use basically, in other math classes when you're not allowed to use your phone, but you are allowed to use your calculator. So it's nice to know. Okay, to the next section, we have the true or false section. And what's happening here, the directions here are, let me scroll down. The directions are explain whether or not these properties are true or false and how you decide. This means to say true or false, right? And then write out your examples and your explanations, like the way you're thinking, that make you believe this. You have to make up your own examples. If you make your example be x plus 5, there are some like simplistic functions that some of these properties will work for, even though they're not true in general. So you want to have, not a super complex function, but something with meat to it. Make sure your examples are two simples. If they're two simples, you might get false positives, right? You'll never get a false negative. If you type in a function and it doesn't work, math only needs one counterexample, right? If something doesn't work, totally false. If something does work, that doesn't mean it's true. We're just trying to convince ourselves here. This isn't a formal proof, but it's a good way to rationalize and reason things. Okay, so let me do my examples. Example number 1. If I go from a to a of some function, will that always equal 0? So I'm going to do some examples. I'm going to say, what if I go from 3 to 3 of sine of x? And what if I go from -4 to -4 of x squared plus 3x minus 9, right? I picked these because I wanted to have a trig function and a polynomial. I wanted to have positive bounds and negative bounds. I wanted to just try everything out. When I plug this into, let's say, Wolfram alpha, 3 to 3 of sine x, I get 0, pretty good. Spoilers, this one's going to get 0 as well. This is a true statement. Here's my truth value, right? Here's my examples. And then my explanation that I'm kind of reasoning with is if we've got a function and the definite integral is the area from a to a, right? There's no area in a single line. So to me, this makes sense that it would be true because we're not going from like A to B and then filling something in. We're simply saying like, what's the area here? There's no area here. So this has to be true. Okay, let's move on to the next one. And this is just like the kinds of things you want to be thinking of, the way you want to be thinking of your examples. None of these examples are on the assignment. Those are all for y'all. Okay, so here I'm saying that if I've got the bounds from a to b of a function, is that the same as the bounds from b to a if I switch the bounds? So in class, we figured out that this wasn't true. But let's figure out why. I'm going to go and say from 0 to 3 of natural log of x. Let's actually make this from 1 to 3. Make our lives easier. And then from 3 to 1 of natural log of x. So over here, so ln of x from 1 to 3, we get 1.295, 1.2958. And then if I instead say from 3 to 1, we get the negative version. Except it's not 9.2, it's 2.9. There we go. So we're going to say this is false. We don't really need an explanation for this because we have a counterexample. So counter example, it's something that proves that this wasn't true for some a, b, and f. And it's nice that we could say could have said that this is the negative version of this, and this would have been true. It's a nice fun fact. Nice. And then the third one we're going to explore is the integral from a to b of f of x dx plus the integral from b to c of f of x dx equal to the integral from a to c of f of x dx. This is another thing that we explored in class. I'm going to do this one explanation-wise. I have a function, and I said this was A, this was B, and this was C. If I went from A to B, that's this blue version. If I went from B to C, that's this red version. And if I went from A to C, that's all these versions, right? It's the whole thing. And that makes sense, just as far as picture-wise. The real question becomes, I'm assuming that A is smaller than B, and that's smaller than C when I drew this picture. So I'm going to do an example over here that's a little wacky. I'm going to say, what if A is 3, B is 1, and C is 5? Right? So I want to say, what's the integral from 3 to 1 of some function? Then what about 1 to 5 of the same function? And then I want to say, are these two added together equal to from 3 to 5 of the same function? Right? Let's check it out. So 3 to 1, 1 to 5. We got negative 1.53. We want now 1 to 5, 1 to 5. Right? Now we get 0.25. 64. These two numbers added together. Let's check it out. We got negative 1.5303 plus 0.25664. These two numbers added together are equal to negative 1.27366. Let's see what this one is. So if we go from 3 to 5, we're hoping that it's this number. 3 to 5. And we are pretty close. Probably it's a rounding error. So negative 1.2737. So we're good. This does seem true. Right? We've got our example for our wacky version. We've got our picture for our things like when we're regularly saying that A is smaller than B is smaller than C. But it seems like that's true, even if that's even if the A's, B's, and C's don't line up exactly. So this would be my evidence for saying why I think it's true. So that's the kind of thing we're going to do on the assignment today. Please, if you need help, email me, come to office hours. Don't be afraid to reach out. And yeah, let's get to getting. Thanks, y'all.